Okay, so this lesson is looking at our next new topic, which is parametric equations. And to get started, it's really important to understand what a parameter is. So you can read here in this introductory paragraph a little bit more about specific situations when we might use this, but I'm going to jump down to talk immediately about what exactly a parameter is. So a parameter, which we often denote with the variable t, is used in order to write both of our rectangular coordinates or variables x and y as a function of t. And when we do this, we are creating what is called a parametric equation. Okay, so what it means for us to take x and y and write it as a function of t is kind of denoted here in this second box. So we see that x is set equal to some function f that is defined by the variable t, and y is set equal to some function g that is also defined in terms of some variable t. So it's important to know that f and t are both continuous functions, f and g are both continuous functions, and we're always looking at f and g on some interval for t. So this means that in order to plot points and graph the equation, the coordinates become f of t, g of t, instead of x and y. So instead of looking at the values of x and y, we're actually plugging t into the equations that define x and y, and we're plotting their outputs as points. Okay? This next little bit of kind of new terminology is this idea of eliminating a parameter. So we use this process to change a parametric equation into a rectangular equation. So remember, a parametric equation is when we have that x equaling f of t or y equaling g of t, and we want to take this back to the rectangular equation. So we've done this when we worked with polar, right? We took polar equations and turned them into rectangular equations. And it's important to remember that our rectangular equations rely on the variables x and y, whereas our parametric equations are relying on the variable t. So let's kind of dive into this a little bit more through an example. Example 1 says the position of a particle moving in the xy plane is given by the equation, the parametric equation, x of t equals 4 minus t squared. So I'm just going to kind of pause and write that down here below and tell myself, okay, I've defined x in terms of t using the equation 4 minus t squared. And I've also defined y in terms of t using the equation t cubed minus 1. Okay, we are told that x of t and y of t are measured in feet, and t is measured in seconds. Okay, so that kind of helps us understand the relationship that's going on here. We're measuring time in seconds, and we're looking at a position in the x and y direction of a particle. So the question asks, what is the location of the particle at 2 seconds? Okay, so we need to kind of understand, what does that mean, this idea of 2 seconds? So what is the location of the particle at 2 seconds? What we're being asked to do there is plug t equals 2 into both our x of t and y of t equations. So we'll look at x of 2 and find that that becomes 4 minus 2 squared, which is 4 minus 4, or 0. And so that's telling us that x of 2 is equal to 0. And then y of 2 is equal to 2 cubed minus 1, which we know is 8 minus 1, or 7. So here we've discovered that y of 2 is equal to 7. Now, it's important to understand what this means. This means that at t equals 2, the particle is at the location 0, 7. And what that means meaning the particle is 0 feet. Remember that feet is our unit of measure for our x of t and y of t functions, and 0 was an output of our x of t function. So the particle is 0 feet in the horizontal direction, and 7 feet in the vertical direction. Okay, so just kind of a recap here, we were given two functions, x and y, defined by the variable t, and we were asked to determine the position of this particle in the horizontal and vertical direction given that t equaled 2. So we can also graph the curves that are represented by parametric equations. So here we have our function x equals 1/2 t and y equals t squared minus 3. And you'll notice there's an interval, or given an interval, we're operating just between t values of -3 and 3. So what this means is we have two equations that give us the x and y values, so our rectangular coordinates for different values of t. Okay. What we'll want to do here, and you can kind of see in your notes, is we're going to actually use this information. We're going to organize and understand this information in a table that will allow us to collect all of our x and y points. So to fill out the table, I'm going to call my first column t. So I'm going to collect all my values of t in that first column. I'm going to let my x of t function, which is x equals 1/2 t, be the second column, and y equals t squared minus 3 as my my third column. And then in this last column, I'm just going to collect all of my x, y points. So remember, if we plug in a t value to our x or our y equations that are defined in terms of t, we're going to get an x and a y value. We're going to get these coordinate points, these x, y coordinate points that we can then plot on our coordinate grid, our x, y grid. So we'll go ahead and start analyzing this at these different values of t. Remember, we were given this interval over here from -3 to +3. So we will take a look at these functions when we have t is -3, -2, -1, 0, 1, 2, and 3. Okay, so just like before, we will go ahead and plug in these t values to each of our equations. So here in this second column, second row, we're going to take 1/2, and instead of multiplying it by t, we're going to multiply by -3. And this will give us the value of -3/2. Okay, and the next column, we're going to actually plug in that t value of -3 into our y of t equation. So we'll take -3 and square that value and then subtract 3. So doing that will give us a y value of 6. Now our xy coordinate comes from this x of t value when t was -3 and this y of t value when t was -3 as well. So our point that we're actually going to plot on our graph is -3/2, 6. Okay, the rest of this table can be filled out in the same way, right? Plugging in different values of t to each of your equations. And I'm going to skip the details of that. I think that's something that you guys can handle at this point, but I'm going to, just for example's sake, go ahead and write down what the points end up being. And you can kind of, you could pause the video and double check that you agree with these xy coordinates. But again, all I'm doing is I'm skipping the details of where these numbers came from, because it's just plugging in each of these different t values into your x of t and y of t equations. So our last points are +1, +1, and then 3/2, 6. Okay, so again, what we've accomplished is we have collected all of these xy points that we can now graph on our xy coordinate system. Okay, so we will have -3/2, that first point, -3/2, so we know that that's -1.5, so somewhere your x value is somewhere between -2 and -1, and up here at +6. We then have -1, +1, -1, -2 down here, and then we have 0, -3. And it looks like we have symmetry on the other side, right? We have +1/2 x and -2y. We have +1x, +1y, and lastly +3/2 x and +6y. Okay, so what we have is on this closed interval of t, -3 to 3, we have these specific points. So I'm not going to extend this with arrows saying that this continues to x is -infinity, x is +infinity, because we don't go that far, right? We're restricted in our x values from our restriction in our t values. So I'm actually going to let this parabola exist only between the x values of -3/2 and +3/2. So again, there's no arrow continuing this to positive and negative infinity on our x-axis, right? It's just going to end right there. There are, however, going to be arrows on our graph that I'm going to go ahead and add. So we want to draw arrows on the graph to show the orientation of the curve. So what direction is this kind of movement of whatever particle we might be examining? Where is it going? So if you look in the table, you'll see that as t increased from -2 to -3 to -2, -1, so on and so forth, you'll see the direction in which the points are plotted, and it follows this orientation here. Okay, so that's just showing us the direction in which this curve was plotted. So if you want, you can go ahead and skip to practices 2, where you're given 3 different sets of parametric equations to graph, and kind of try out this skill on your own. Otherwise, go ahead and check out the next video that details examples 3 and examples 4.